So if you look, we have f is equal to -3, g 2, and h 5. So basically all we need to do is substitute it into this formula here. So first thing we want to do is we just want to, if I go around here I can probably avoid, no I can't. Okay, so what we just need to do to start is just substitute it into the formula. So we get it like this. So we have -3 squared, which is the value of f, -5, which is the value of h, over 2, which is the value of g.
Can anyone think of any better way that we could do that before we carry on, Paul? There's only one thing I do differently, can I?
You can't have a -3.
Yeah, I get brackets around that -3 because that f, so I'm going to come and add those in here. This is a nice moment, isn't it? Okay, like that. Does that make sense? -3 is squared. If you put that into your calculator, which I know is a non-calculator paper, but if you did, your calculator would give you -9 because it's doing big numbers. Okay, sorry, we'll carry on.
So, and then you can just start evaluating that. So -3 squared is, of course, -3 times -3, which is equal to 9, because a minus times a minus equals a plus. So we do have 9 minus 5 over 2, which is then equal to 4 over 2, which is simply equal to 2.
Excellent, very good. 2 marks. Circle those, you've got those, perfect. Okay, do you want to talk me through B as well?
Okay, same procedure as before, you just do it with just h this time. So we'll keep it in brackets to start with. So if we do 2 times, and then h is equal to 5, so we do 2 times 5, and then that'll be 2 times 5 cubed, which is the same as 10 cubed, which is equal to 1,000, because it's the number here is equal to a number of zeros when you're cubing by 10.
What does cube really mean then, Paul? That's a good
It'd
trick
be-
for that, I agree with that.
So if I just write underneath, that would be 10 times 10 times 10.
But the trick you use here is really good when you've got 10.
But if you ever do a 10 to the power of n in this case, the result will always be 1, and then the number of zeros, which is in n. So if we say we had 10 to the power of 5, there'll be 1 followed by 5 zeros.
What about 10 to the power of 7?
There'll be 7 zeros.
Can you write it out? Just so I can see it later. I sort of
No,
refer back to
David.
it.
Thank you very much, Steve. Thank you for your support. Okay, excellent. Another 2 marks there for having 1,000. So well done. Mark these if you got them. Okay. And then C, can we move? Just pick up the camera and move it down. Pick up one place. There you go. And then you should be able to see in the laptop there.
There we go. Cool. So, same procedure. We just substitute in the numbers, so it'll be 2 minus -3, and I'll put that in brackets to clarify, plus
You should do, to be fair, you should be doing that.
1 over the value of h, which is 5. And then you work that out. So, of course, 2 minus minus is equal to a plus, so that will work out to 2 plus 3 plus a fifth. So, from there we do 5 plus a fifth, and I cannot remember where to go from this. I'll convert it into a decimal because I can do that in my head. No, I can't. No, it's which is equal to 5.2, because a fifth is equal to 0.2.
I like that idea. I think that's really clever. Could you have written it as 5 and a fifth?
Yeah.
You could if you wanted. It's a mixed number.
Of
Can
course.
you write it as a top-heavy fraction?
I'm a smart person.
Want to say again, Ruth? Absolutely. Okay, any of those answers would be fine. In my mark scheme, it would say except 5.25 and 1/5, 26 and 5, or equivalent. Those things, what we said, are all equivalent. Okay.
So 5 plus
5, and then you put them together, because if you do 5 and 1/5, you're sort of leaving it, you're not simplifying it, but 5 and then the fifth next, so it's fine. Rachel, any questions?
So like 2 bit 5 1/5 of 5.2 would be right.
Perfect, yeah, either of those would be absolutely fine.
Like, does it matter if I put both down?
No, not at all, not at all. If you put both down, not a problem. Okay, are we liking this idea? I think that worked quite well. Are we happy to do this? Yeah, so I'll go and do one from the back and then we'll go back to the front. Is that fair? So it's going to go easy, hard, harder, well, getting in the medium, then sort of like medium-ish with me, and then we'll get to B. Okay? Thank you, Paul. Okay, so let's just check this is recording. Yeah, we're all good. Oh, okay then. How do we feel with this question here?
Terrible.
This one's a bit of a fussy one. I can see why you didn't like this one. Okay then, so let me just focus in a bit clearer. Okay, better. Okay then guys, 3, 2, and 1. Thank you very much. Okay, the first bit for me, these 3 marks here, they're not too bad because you can think of it in a very, very specific way. We're told that Rodri has 4 pairs of shoes. He's all got terrible dress sense because he has red, purple, and white shoes. They're quite standard. If you look down now, I bet most of you are wearing black shoes. But the red and purple, white shoes, don't know about that. Okay, so he has 4 pairs of shoes. So if I've got 4 pairs of shoes, how many of those shoes, those individual shoes, will be purple? 2 of them out of 8. Okay. Now, if he goes in and selects a purple one, he had a 1/4 chance. Okay. But say he then selects one of those purples, he now has 1 less next time he goes back in to grab. Yeah. But he also has 1 less overall, so it's going to be 1 out of 7. Okay. If I multiply those together, I get 2 out of 56. But that has done completely the opposite of what I just said. This says 2 shoes, neither of which is purple. I've just got them worked out, chance of actually getting 2 purple shoes. Now, some people look at that and say, well, what a waste of time. That's completely didn't help me out here at all. Luke, go on.
It doesn't say that he's taken 1 out. And then
It doesn't, does it?
Yeah.
It's expected usually in GCSE questions. It does really state like really, really, really obviously. It'll say without replacement in bold letters. But if I go and select 2 shoes at random, it's pretty obvious, isn't it? If I select 1, there's going to be 1 less next time, isn't there? Okay. So can we make that reference on our paper? Can we say without replacement? Okay. So this is the probability. I say P bracket, it just means probability of, it's like a shorthand way of doing it, both purple. Now we're going to come back to this method in a second, so I'm going to show you like the other way to do it. The other way you could do it is by starting to draw probability trees. Now, I know there's 4 different options here. We've got red, purple, black and white, but we only really want to have 2 branches on a probability tree, because otherwise it's too hard to try and work out all the options. It gets messy, okay? And the fact that he wants purple, I'm going to do it as purple and not purple, okay? And then from here, again, purple and not purple. And from here, you could have got a purple and a not purple. All good? So the chance of getting a purple I've already done, that's 2 out of 8. And I've actually done this branch here as well, which is 1 out of 7. So what's the chances that he got a purple the first time, then he went in and didn't get one, which was purple?
6 out of 7.
Brilliant. Okay, remember the branches always add to 1, so 1/7 plus 6/7 equals 7 out of 7, 1 whole. Then here, not getting a purple the first time was 6 out of 8. Then not getting a purple again would be? Excellent, 5/7, and this would be 2/7. Which ones am I interested in out of these branches? It says neither of which are purple. So neither of which are purple is just that one there, isn't it? Agreed?
Yeah.
This one here, he did get the one that's purple. This one here, he did get the one that was purple. This one here, he got both of them were purple. So this one here, actually, I've realised I misread the question, and that was irrelevant, okay? So sorry, that's my fault. So neither of which are purple would be 6 over 8 multiplied by 5 over 7, which is 30 over 57. Do I need to cancel that down?
56.
56. Just checking. Do I need to cancel that down? No? Does it say anywhere to cancel it down? It's the last page. Just check you can do your probability stuff. The 3 marks come in from knowing all this stuff. If it said cancel down, you should do. And if you want to, by all means, go ahead and cancel down. But if you do it wrong, you're going to lose a mark there. You won't lose a mark if you left it as 30 over 56. Paul?
I did it as 3/4 and 1/4, so I got 15 over 28, which is just a cancel down version of that.
Yeah, that's fine. 3/4 and 1. Yeah, fine. Absolutely fine. A matching pair of shoes. Now, this one is worth more marks. It's a little bit more tricky, but again, we want to try and do probability trees and try and think about like the steps that are happening. So I'm going to focus on 1 pair of shoes. I think I'm starting to do this here. Okay. Now, if I did like probability trees and I did like going here, 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 and here. I mean, for me, that's starting to get very messy already. I don't really want to do that. What I could do is I could physically look at it and say, what's the chance I get a red, then a purple, then a black, then a white. But then I'm not interested in the other option. I'm not interested in not getting those. So from here, I was only interested in getting a matching pair of shoes. So I could say, then I get a red again. Not interested in any of the other options. Then I get a purple again. Then I get a black again. then I get a white again. It's up to you. You could do that. For me, what I would do is I'd go and work out the probability of getting just one where they're a pair, which is 2 out of 56. And how many different colours were there? 4. So what do you think I'd do to the 256 and the 4? Times by 4. For me, that's the quicker way. But you'll find that it would work doing it what we did here with the branches anyway. Okay? So from here, I had a 2 out of 8 chance, then a 1 in 7 chance. This was a 2 out of 8 chance, then a 1 in 7 chance, 2 out of 8, 1 out of 7, and again. And can you see how it's just these numbers repeated? That's why it's going to be that you multiply it by 4. So 2 out of 8 times by 1 over 7 gives us that 2 out of 56. And then 2 out of 56 multiplied by 4, because there's 4 different colours that I can make, would give me, any ideas? 8 out of 56. Do I need to cancel that down? No, it's up to you. Okay, all good? Fantastic. Okay, question 2 is a group frequency distribution. It says, can you draw a group frequency diagram? So anyone really confident with this? Think, remember what it is? Luke, do you want to come?
You might need Lloyd's ruler, so.
Yeah. Is it? We're okay, we've got one around, have we? Do you want to use the red ruler for now? Are you going to be happy with that one, or do you want Lloyd's?
I'll be fine with this.
Do you want to explain what you're doing?
Yeah, I'll just wait. Alright. It says 50 to 55 is 4, so we find the scale, which is 1 per square, so we go up 4, and we draw the lines.
Okay, now, one thing that I would like to see you doing, okay, when you see this word, group frequency diagram, I would underline that and say that means bar graph. Okay? Because that could look, the question could look identical in everything apart from one word there, and it would be a completely different thing that you do. The word that could change is diagram. If that was polygon, which obviously it's not, but if it was, it wouldn't be a bar graph. It would be a line graph plotted at the midpoints. But it's definitely a good idea to just look at the word diagram, underline it, and say, look, this is a bar graph. I know it's a bar graph. Okay? Well done, Luke. You did a great job.
And then we go 55 to 60 is 18, so...
And luckily for you, they already have the axes filled in. And the key mistake that I see here is between 60 and 65, people don't write that as what we call a continuous scale. They write underneath the bar as if it's like a thing for like cats and dogs, like a bar graph like that. You don't write it like this in between. You write it so it's a continuous scale. So you've got 60 on the one end, 65 on the other. Okay, that would be wrong.
And then we do the same for 60 and 65. And then 65 to 70. And then 70 to 75.
Okay, hopefully it'll be quite a nice scale. It's going up in 10s, perfect. That's exactly what we want. If it's going up in 20s, it's a little bit fussy. Try not to go on the papers and the other words. Oh. I'll move it. It's not the best place to have it, is it? Okay, all good?
Can I turn it over?
Okay, John, I think it's this one here then.
Alright. And from this it says frequency. Oh wait.
Feel free to pick up the
Because-
camera and move it so you can see bits and bobs of it.
Oh yeah, that'd be helpful.
Yeah? Oh, there's like 2 monitors there you can check.
I'll just do the first question. It says how many logs did Billy collect and measure. So then, because it's frequency, we can find out that there's 20 there, and then there's 30 there, and then 15 there, 5 there, and 5 there.
I'm a big fan of doing what he's doing here. I usually write on the top of the bar, but in the bar is absolutely
Right.
fine as well.
And then that's 5 and 5. And then we add them together, so it'll be 20. Which equals 75. Right?
All happy with 75?
Yeah.
Yeah, 75. Was it Tom or Billy who collected the longer logs on that?
Now, if you look back at the other one, if you look back can you get the grass side by side? That will work?
If I hold it
Yeah,
up.
hold it there, perfect. You should be able to tell which one just from the generic distribution of that. Lewis, any idea?
You can see that it's Tom on the left.
The one on the left, yeah, I agree, is this one, isn't it?
Because you can see that the longest length you're looking for is the one at the end, which is 70 to 75. And you can see that Tom has got more. He's got, is it 10?
That's a really good point. I wasn't even going for that one. I think that's a really good point that you've made. I was going for another bar instead, but I think your argument absolutely stands up. Which bar do you think I was thinking of? Anyone else who's not Lewis? Right? Yeah, if you have a look at that bar there, this 60 to 65, do you want to point to that one with the pencil if you can?
Oh, God.
There we go, thank you. This bar here peaks between 60 to 65, whereas this bar peaks, its highest bar is between this one here, which is what, lower, 55 to 60, is it? All good? Thank you very much.
Don't put it down now.
Maddie?
I did a range from 60 to 75. Is that still okay?
Yeah, it's fine, yeah. As long as you come up with some sort of argument along those lines, okay?
Yeah.
All good? Excellent. I've got to say, Paul and Luke have not only come up and given really good answers so far, but they've also worked out that it's probably going to get harder as we go on through the paper, so I think they've just thought, right, I'll get in when it's an easy one. Am I right, boys?
Yeah.
Yes, true.
I had that perfect.
Okay, I've got a very, very, very similar question to Luke, but this time it is right at the back of the paper. So on the face of it, it looks identical, doesn't it? What's the difference? Frequency, density. So I'm going to set it down here. Excellent. As soon as I see that word, I would go and right next to that, FD equals F over CW. Maddie came up with that, didn't you, Maddie? You like it as F. FD equals F over CW, don't you?
No, GW.
No, CW.
No, GW.
CW. Thank you. Thanks, Maddie. Okay, moving on. Okay, it says calculate the number of people. Now that just means frequency. Number of people, posh word for that is frequency. Okay? Common misconception, people say, oh, 0.2 people belong between 0 and 30. Well, that's nonsense. You can't have 0.2 persons, can you? So what I need to do is to rearrange my formula to get frequency on its own. So I'm going to bring over this divide by CW as a times by CW is equal to F. Okay? So 0.2 times 30, don't know that off the top of my head. 0.2 is the same as 20%.
That'd be 6.
10% is 3, 20% would be 6. There's a load of different ways you could do that, but it's definitely 6. Okay? So the same sort of idea as what Luke did, write the number in the bar. This one here, group width, class width of 10, up to 0.4, that's much easier, 0.4 times 10. 4. Now bear in mind, the area of this bar compared to this one, I'd expect this area to be bigger because I said there's 6 people. Is that bar actually bigger than that bar here?
Yeah.
It is, isn't it? Yeah? Good. Good. Okay, this one here, 8. This one here, 12. And 10. This last one looks a bit fussy because it's in the line. You can quite clearly see they've gone in the middle there. So would that be what? 0.1?
Yeah.
Yeah? Times by 30, which would be? 3. And that's the half size, half the area of the 6, so it seems to make sense. So it says calculate the number of people in the group. So it literally be 6 plus 4 plus 8 plus 12 plus 10 plus 3, which is? 43. Okay. We had a question, I think, pretty similar to this bit here. It says calculate an estimate for the number of people who climb the stairs in less than 65 seconds. So what I need to do is come up to my graph here, find where 65 is, which is bang in the middle of 65 and 70. Cut it there. That's at 65. Okay? I was asked the number of people who did it in less than 65 seconds. So which side of that line do I want? Left-hand side? Okay. Here, so it's these 6 people here, plus the 4 people, plus the 8 people, plus the 12, and then plus half of whatever this category was, because I've chopped it bang in half, haven't I? But if it was like 62 seconds, I'd have to use this formula here again, and then work out, so it'd be a group width of 2, frequency density 1, 1 times by 2, so it'd be 2 people, okay? But in this case, it's quite simple, it was plus the 5. Or I could have said that's 43 there, take off the 3 there, and then take off 5, 35.
Yeah.
Okay, so there's a couple of different ways you can work that out. So my answer is 35 peeps. Yeah? Make sure you do write people. Don't write peoples. Okay. That's your fault. 6 plus 4 plus 8 plus 12 plus the 5. Okay, all good?
Next question, sir.
Okay, so I've got that one there.
This one was so good. It was my favorite.
Do you want to come up and do it?
It'll take a while.
Come on,
Come on, it's fine.
It's a very messy piece of work.
Well, you're writing it out again anyway. By all means, if you've written it out, come up with your solutions. That's absolutely fine.
written it neat? I actually haven't written it very neat. I might
No,
get
you're
lost.
coming up and writing it down.
Oh, okay.
And you're going to try and not wheel over all my papers.
Don't do it me.
Alright, guys, you better focus because it's hard.
Okay, nice and quiet. Okay, I'm happy with what he's doing here, that's fine.
Ooh, sorry.
Great
Okay.
stuff.
So we have a nice group of information here. So this is the amount that she's used to serve 4 people, and then we have the nice little equations which are going to help us to find how many serve 8 people. So let's see if we can fit both. Perfect.
Pull it up.
Up this.
The
this.
camera. The camera.
Isn't that right? Can't you see?
Yeah, you can see, it's fine. You're fine.
Cool. Okay. So we have 4 ounces at first. So to change that into grams, so now we have 4 ounces is 115. So times that by 2 because you're serving 8 people is going to be 330.
Can I make a point there? I
Yeah.
did this question, like I was tutoring someone, and I failed it, so I just changed it all into grams, so I didn't double it. So the key thing there that you need to pick out is that that's 428. So you need to convert everything, and once you've done that, you double it. You could, if you wanted, double all of this, then convert it and do the same thing. Okay, but well done today, because I felt that was quite an easy one to miss. I missed it myself.
150 is
Oh, it's 230. That's right. Sorry, my bad.
He's just checking out the thing.
230. Yeah, on camera. Check and make sure everyone's right on it. And then we have 8 ounces of asparagus. So 8. I ended up with 450. I don't really know how I did that, but
Right, thanks for talking this through.
Yeah.
So clearly. That's the thing.
okay, fine. Let's see how it happened.
460. Yeah, 460. Yeah.
Oh, it is 60. Sorry, I read it 50. Sorry, it is 60. It says 60. Is that okay? Do I have to explain how I did that?
No,
Yeah.
yeah,
Yes, please.
Are we happy? Or it's up to you. As a class.
Yeah.
Is everyone?
No,
Are we
go
unanimous?
through it.
No, Luke. You could just go through it at home, right?
Can you go?
Yeah.
I can't go through
Something
it.
else is correct.
Right, the first two are 230 is good, 460 is good, yeah?
We'll get to that. Okay.
Dave, can you work?
Right,
I think
okay.
the next one is right.
690.
On the second
Yeah,
to last
that's
bit.
right.
690. I'm happy with the 690.
Okay. 2 onions. Is everyone okay with that? Cool. Okay. 60 milliliters of stock.
Yeah.
So 50 mil in the first one, what was it? A couple of teaspoons.
It was 2 tablespoons.
2 tablespoons. One is 50. So 2 would be 30 and then double it because it's right. Okay, yeah.
Got it. Okay.
I
1.2.
bet a large sum of money that that's not correct.
No, it's not.
1.2 millilitres.
Oh, that's stressful. Right. Okay. 2/3 of a cup.
Yeah, 1.6.
Okay, should we do a little bit of work for this by the side? Do you want to jump in?
Do you?
Yeah? Don't worry, you're doing fine. You're fine. Okay, 5, 4, 3, 2, and 1. Is actually this is really good. I'm really pleased this mistake's here because it's important that you're actually asking yourself these questions, and when you can't really sort of force it at the board, but gives me a really nice chance to talk about it. 1.2 millilitres. Well, in a teaspoon, that's 5 millilitres. Okay, so you're looking at 1/5 of a teaspoon of liquid. It's probably not right, is it? Okay. So if you're getting an answer like that, just think about it. Just think, does this logically make sense? Does this actually seem to make sense? And if you're there looking and going, no, it doesn't, that's when you go back and check your work, okay? So we're told that a cup is 240, that's this bit here. So 2/3 of it, how do I find 1/3? Divide it by 3, so 240 divided by 3, 224 divided by 3?
That would be 80.
8, so it's going to be 80, and that's 1/3, so 2/3 would be
160.
160. So that is for 1/3. So 2/3 is 260, and then that's for 4 people. For 8 people, I need to double it. So I needed to do 160 times by 2, which is 320. All good? I'm pretty sure the next bit here, 86.25, is right.
It's 172.5.
Yeah.
Okay. Oh, I know what you've done then. I've got a gut feeling that you just didn't double this. I think if you doubled that, would that give the answer you just gave me by any chance? Okay, so 3 ounces of cheese. Now this one for me did cause the most headache. So if I do this in red, we're told that 4 ounces is approximately, so I'm going to write this up by here. 4 ounces is approximately, so I just say is equal to 115. Then 2 ounces must be half of that. So half of 100 is 50, half of 15, 7.5. So that's 57.5. Oh, wrote it in. Is that 57.5? Okay. Now I need to find 3. So if I go and find 1 ounce here, which is quite easy, I just halve the 2 ounces. Half of 50.
25.
25. Half of 7.5.
3.75.
Excellent. 3.725.
Oh,
3 point, no, you're right. So hang on. So 28.75 altogether. Yeah, we agreed with that?
Yeah.
So to find 3 ounces, just add together 2 ounces and 1 ounce. So 2 ounces add 1 ounce would be 3 ounces. And then the 5 here on its own. Then the 12, carry the 1 over. 8 and 8 makes 16. Carry the 1. 2 adds 5 is 7. Add this one here is 8. So that 86.25 you had down here is actually grand, but you've done it for 4 people, not for 8. So all you need to do is double the answer. So double of 80,
Oh yeah, so 160.
160, double of 6,
12.
12, double of 0.25, 5. So it would be 172.5. Okay? All good?
Yeah.
Happy days? Yeah?
Can you have a look at this?
What's that, sorry?
Can you have a look at mine?
I can come have a look in a second. Yeah, I'll just finish off by here. Are you happy to come up again and explain what you did next? Or you're probably going to have a few issues that you had the cream answer wrong by here. But will you talk through your theory of what you did, David? Mind coming back up?
Yeah, sure. I'm back. Okay, so the question says Samara has half a litre of carton cream. So she has large quantities of other ingredients and calculate the largest number of portions of pasta with cheese and asparagus sauce that Tamara can make using as much of the cream as possible. So, what I did, which is probably wrong, that's okay.
It's not okay.
How many portions did you get?
I don't know. I think it's best I don't explain it. I can play elevator music, so when you're revising,
Yeah.
kind of like.
Right, do I need to jump back in, David?
Yeah, that'd be great.
Okay, so going over the next bit, it says Tamara has half a litre of cream. So what they're looking for this bit here was that you could convert the cream, half a litre, they gave it to us in millilitres here. So half a litre is equal to how many millilitres? 500 millilitres. Now, we know that 8 people would be equal to 320 millilitres, agreed? I know that 4 people from my work before is equal to 160 millilitres. If I add those together, can I just finish this bit, Lewis, and I'll come back to you? Is that right? That would give me 12 people would have 480 millilitres. Now that's looking pretty good, so I'm guessing it's 12, but it may be 13. How could I work out 13?
You divide it by, like, you can divide the fourth thing.
Well, I could do 4 divided by 4, which would give me 1 person, so then I'd have to do, that would give me 1 person. So I divided that by 4, so divide this by 4, 40 millilitres. So if I added 40 onto that, that would give me 13 people need 520 millilitres. That's too much, I've only got half a litre of cream, so the answer is 12 people. Okay, does that make sense? Okay, Lewis, your question first?
Oh, don't worry, it was just like a sort of quick away.
Oh, go on then, what's your quick way? I'm always
It was
interested.
just, you know how you've got, you know the 500 millilitres
Yeah.
is what you want, yeah?
Yeah?
So, and you know the 240 millilitres is 1, like, cup?
Yeah,
Yeah, it is.
2/3 of a cup is enough for 4 people, which is 240.
Oh, don't worry, I did too.
You all done?
Yeah, I got the same.
Yeah, I'm sure there's other ways of doing it, but if you, Lewis, on a serious note, if you ever know a quicker way, please tell me. I'm always interested to learn as well. Rachel.
You know, on that.
Oh, 1 second, Rachel. Can I be quiet, please? Thank you, Year 11. Thank you. Go, Rachel.
You know, with all the answers, such as vectors, parameters, pasta, onions, and all that.
These ones?
Are all of those right?
Yeah, they're all now right. Okay?
So I got all of the ones on that part, the last two. So how many marks?
Oh, okay, what a great question. The mark breakdown of that. They would have probably given, without actually having the marks given right in front of me, if I had to guess, the 4 marks from here, I would have thought they're lumping together. These, I would have thought these 3 would be lumped together as a mark, because they're all sort of related. Then I would have given that a mark. No, I wouldn't have given these 2 a mark. The onions and the stock, and then I would have given 1 each for these. Okay, that's how I'd split up the 4 marks if it's me marking it, but I would need to double check on the marks. Good question. All good? Just going to do one from the back. Okay. Oh, transformations. This is working also on transformations. Okay, and a bit of search. Right, we've got some really good A-level. Well, there are A-level topics here. Rational numbers as well. Excellent. I'm really pleased this is going over and we're getting recorded. Okay, then, guys. 5, 4, 3, 2, and 1. Thank you very much. Thank you. Still waiting. Thank you. Okay. Now, these dots here mean that these 2 numbers are repeating. Now, when you set this out, it's absolutely crucial you know how to set this out the right way. So I'm really pleased this is getting recorded because it means that you're going to be able to go back and actually check how I set it out. Leave out 2 lines and then write x equals, but space this out, and then you say 0.342727, blah, blah, blah. The 2 and the 7 are repeating. That's what this dot on the head of the 2 and the 7 mean. Okay? Now from there, I want to basically start taking this away so that it all cancels out. So whatever this dot, however many dots I have here, I times by 1 and that many zeros. So 2 dots would mean 1 and 2 zeros. So in other words, 100. If it had 1 dot on it, I would have times by 10. If it had 3 dots on it, I would have times by 1,000. Okay? Now I must line up the equals and I must line up my decimal point. If I don't do that, this is going to be too hard to do this question. Times them by 100 shifts everything along 2 places. So that 3 and 4 shifts up to being 34. Okay? The 2 and the 7 shifts above the 3 and the 4. And then 2 and 7, 2 and 7, dot, dot, dot. Yeah? So what I do now is I subtract them. What's 100x take away x? 99x. So again, lining up your equals 99x and then your decimal point as well. The 2 and the 7, look, these are going to cancel. Cancel, 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 cancel. 7 take away 4. 3. 2 take away 3. Excellent, -1. We don't want negatives here, so what we do is borrow. Can you remember doing that? Probably been a while since you've done it though, isn't it? 12 take away 3. 9. 3 take away nothing. 3. And then 3 take away nothing. 3. So then as a fraction, I would have 33.93 over 99, but there is an issue with that.
You can't have a point in a fraction.
Excellent. You're not allowed to confuse decimals and fractions. They're separate things. They do the same thing, but they're separate. You're not supposed to have them mixed together. So how can I get rid of this decimal point here? Times by 100, but whatever I do to the top, do to the bottom. So my final answer is x equals 3393 over 9900. Okay? There are different ways to do it, and if you're comfortable and you're confident with the way you're doing, absolutely fine. If you're not and you like the way I just did it, then go back and watch it in the video I'll post up on Edmodo.
I think it's because when we were taught this, it's like when stuff came up like this, we were always taught to have the same sort of decimal places. So
Yeah.
Ours would be like 10,000 next time.
Yeah, I always find that really confusing. I never got that, and my way does always work, but you sometimes get a decimal in a fraction. As long as you remember to times by 100 or times by 10 or whatever you need to, it's fine. It still gets you full marks. Okay? All good? Right then, what does this word rational mean? So we can't really go any much further on this question or the next 2 questions without understanding what it means to be a rational number. Stefan? Oh, you've been doing your revision. Excellent. It is an integer divided by another integer. So any number that could be written in the form of just something divided by something else, that is what we call a rational number. Okay, so 3 is a rational number because I could write it as 3 over 1. 2.5 is a rational number, so I could write it as 2 over 5. 2/5 is a rational number because it's already written. It's an integer divided by another integer. What about 0.33333 recurring? What would that be? Would that be rational or irrational? Sarah? Why? On the face of it, 0.3 is like just a long, never-ending number. Ed? It'd be a third, wouldn't it? That is 1 divided by 3, so that would be fine. So 0.66666, that would be rational as well. The ones that are irrational are never-ending, never-repeating numbers. So the ones you should be thinking of that are really obvious irrational numbers. Pi? Someone said it then, so beat me to it.
E.
How do you know what E is?
I don't know, it's on the calculator.
Oh, very good. E is also an irrational number. I'm impressed that you know that, but don't worry about that. Ed? Excellent. Surds are irrational numbers, providing you're not square rooting a square number. Okay, so the square root of 36 is a rational number. Square root of 37 is not. Square root of all the way up to 48 then, if you go up in whole numbers, are rational numbers. Okay, so it says, give an example. It says, write down 3 values of x for which x to the 3 over 2, power of 3 over 2, is rational. Well, what this 3 over 2 means, the over 2 bit means the square root of x, and then the cubey bit here, or the 3 up at the top, means I cube it. Okay, that's what that means. So basically, pick any 3 square numbers. Give me a square number, Reese. 4, and another square number? Is that a square number? 16, and another one? 9. Those 3 are fine. Any square numbers, 100 would have been fine. Paul?
So doesn't E have to do with like logarithms or something?
Yes, it does. It is the, yeah, if you look at, we won't talk about that now. We'll do the GCSEs. Okay, that's give an example of a rational number whose square is rational. Well, we've more or less answered that. Any ideas? Go on, Ed.
I just did square root of 3.
Square root of 3, absolutely spot on. Square root of any number that is not a square number, okay, as long as that number in here isn't a square number. Because when you square it, your times by itself and the square root's cancelled, giving you just an obvious number. So like root 3 times root 3, be root 3 squared, the square root cancelled, giving you just 3. Okay? Give an example of an irrational number whose square is irrational. Now, we've actually done that as well. Go on then, Ed.
I do pi.
Yeah, I do pi as well, and I think Rachel, you gave it as well before. Pi. Fantastic. Very good. Very pleased with that. Someone ask me a question then? Yeah, Maddie.
How is 3 irrational?
How is 3 irrational? It's not. It says give an example of an irrational number. When it's squared, it's rational. So root 3 times by root 3 would be root 3 squared, and they'd cancel just leaving 3. Okay, so its square is rational, but it's originally irrational. Okay?
Surely if you
Go
square times pi square times
So what is pi?
pi is 3.14.
141592, blah blah blah. Massive long number. If you go into Mr. Jones's room, you'll see how long it is. It goes all the way down to classroom, and it still doesn't end, doesn't repeat. If you times that by itself, you can do 3.1414 blah 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 times by 3.14. That's not going to go to being a whole number, is it? I can't ever see that being a whole number. What's that? Sorry. What if you need to write it as a fraction? No, that's the thing about pi. It's never ending, never repeating. It hasn't actually got a fractional answer. The closest fraction that it's closest to is 22 divided by 7, 22 over 7. Okay? What's that? It genuinely doesn't finish. Okay? Right then, this one here. Root 32 plus root 2. There's 2 methods, and I want to show you both, because I was showing someone in year 9 in another school. We were talking through it, and she had such a clever way of doing it. And the way I did it, the lesson before, was really long, but I'm going to show you both methods. The default method I would go into, I'd say, well, squared means times by itself. So if I had root 32 plus root 2, I'd write it as times by itself. And then I'd do FOIL on these brackets. So root 32 times root 32 is 32. Root 32 times root 2 would be root 64. Then plus another root 64. Then plus 2. 32 add 2 is 34. Root of 64 is 8. So plus 8 and plus another 8 would give me a final answer of, is that 50? The other way we could have done it, that wasn't too bad actually, that one. The other way we could have done it is we could have said, right, root 32, what's the square number that goes into 32? Oh, someone's actually answered it for me. It's 16 times by 2, which is then 4 root 2. Yeah? So we could have said that is 4 root 2 plus root 2, which is 5 root 2 squared. So then it would be 5 squared, which is 25, multiplied by root 2 squared, which is 2. 25 times 2 is 50. Which one do you prefer, red or green?
Neither.
Okay. Actually, working out this way is actually quite hard. It's not as easy as the other way this time. But the time before was actually much easier to do it that way. Pick one, stick with it. This one will always work. It does repeat work, you know, from expanding quadratics and stuff like that, or expanding double brackets to get a quadratic. I wouldn't go into the exam going, oh, I could do this two ways. I just pick one way that you're confident with. Okay?
I got 48.
48. Well, can you make sure you got your correction? Because it's definitely 50. Yeah? Anyone want to come up and do the enlargements for me? Come on then, Josh, up you come.
I should have done that. Alright.
What was the final answer?
Laughing, don't?
Oh,
Where's that pencil go?
Oh, here.
oh, D.
Thank you.
Oh,
Okay?
No.
oh, John.
You can start.
Shall I just start?
Yeah.
Okay, everyone quiet, please. Quiet.
Right then, guys. 3, 2, 1.
Take charge.
Okay, so this is how I do it for enlargements. So the scale factor is 2, so we times everything by 2. So what I do is for A, I go 1 across and then 3 down, and times it by 2, so I go 2 across and 6 down.
I love it. He's explained it perfectly, okay? When he said you go from here, you go from this centre of enlargement, you count where it is, 1 across, 3 down, then you reset, you go back to that centre and double everything that you just said. Perfect, well done.
So then we do the same for each side. So it goes. Oh no, I did it differently. So I start off by there, and I see that goes diagonally through 2. So then I'll put that diagonally through 4. Just by
Be
there.
careful if they're not true diagonals. In this case, it's fine because look, you can see it goes through corner to corner. But sometimes you'll see the odd one that goes like through like that, like down 2 and only across 1. So if you've ever got that, just be careful of those. But what you're saying is absolutely fine.
So then I go down 2, so be by there, and diagonally through 2 again. And I do it so they meet. Should be there, because I can see it from the first point to that point. They just meet. Yeah. And then I'll draw them in. That's not very straight.
That's fine, that's honest, that's fine. Perfectionist.
That's not funny. And this shape.
Okay, now it should look, an enlargement is everything's getting twice as big. It shouldn't look like just pulling it, like squeezing it down, stretching it out, stretching it to the side. It should look that it's like everything's been grabbed from the middle and I pulled it out every direction. Okay, there is a way that you can check. Does anyone know how you can check? You can do something called the Ray method. I'll just do it on the board rather than messing up his work because it can mess up your work, but it's nice just to be certain if you're unsure. You draw a straight line from there, you go through the corner there and see if it carries on like that, but you do it from every corner. So like I said, it's not great on the board without using a ruler, but you can do that check, and it's not a great one to really check with as well. But if you got your ruler and it was going through each corner, then you'd know you'd be fine. Okay? The bell's just come to the end of that lesson. Are we happy doing this? Do you want me to carry on doing this?
Yeah.
Ruth? Yeah, do you want to grab a tissue? Should we just stop for the moment? We'll stop on there and just have 2 minutes. Refresh.